Thanks very much, Carl. The talk today will be a little bit different from many of those that I give, in that it's more of personal reflections on what I think are the big challenges facing us as a species in the 21st century. And I'll spend about 3/4 of it talking more about what I think the solutions might be or the directions forward. The first quarter I'll talk about this idea of the Anthropocene for those of you who haven't come across it before. So there'll be 4 parts to it. Let's get right into it then with part 1, the Anthropocene. This is a term that was originally used by Paul Crutzen, who won the Nobel Prize for chemistry in 1995 for his work on the ozone hole. And he uses it to describe how we as a species have gone from being hunter-gatherers, people who live very lightly on the land, to being people who now are a global geophysical force. So let me, in just a few slides, try to describe what we mean by the Anthropocene. And I'll start first not about the biophysical environment, but about humanity, about ourselves, and how we've changed. And here are just a few ways in which we've changed. The first one, and I think the most important one over the last 100 years or so, has been the spread of Western consumptive culture virtually everywhere. That's been what's driven the huge acceleration of human activities over the last, particularly the last 50 years, but over the last century. And if you travel to India, China, South America, Africa, and so on, it looks more and more like the Western world, and people are living more and more like we do. So this type of culture, which is based on high energy, high consumption, is spreading everywhere. Now, as a part of that, another trend that's occurring is the strong increase in the rate of urbanization. Now, why is this important? I believe it's really critical because it changes the human-environment relationship very fundamentally. If you look at people in urban areas, you could argue that they actually know more about the environment, and they do in a theoretical, in an academic sense. Most of you, most of my colleagues have studied biology, ecology, some sort of environmental studies, and we know about it in some way or another. But the people who lived on the land and still live on the land have a more practical understanding of the environment. Another way in which it's different is we start to lose our connection of what we draw from the environment in terms of services. For example, those who live in a city like that one there probably don't have any idea where their food really comes from and what it means to grow that food, what energy, what materials go into growing that food and transporting it, and likewise for other services that they draw. So over the last 30, 40, 50 years, we've fundamentally changed our relationship to the natural environment around us. Now, being a global geophysical force, we should be able to see our imprint on the Earth, and indeed we do. Our biggest imprint, in fact, is arguably not on the atmosphere, it's on the land, because we are terrestrial creatures and we've been modifying the land for a long, long time. But again, in the last century or two, the transformation has been enormous. It goes all the way from huge landscapes like this, which are basically industrial. The rivers are straightened, everything is planted in nice, neat rows and so on. It has really very little relationship to a natural ecosystem, all the way now to what many people call a new frontier, which is the genetic one. We're changing a lot of the terrestrial materials that we rely upon in very fundamental ways. We can see the imprint in other ways. We can see it in the diversity of the biology of the planet. And this is some work from the Millennium Ecosystem Assessment, which indicates that the species extinction rate has grown enormously the last couple centuries. It could be as much as 1,000 times the normal rate at which species go extinct. And if you look at the future, I find this a pretty frightening figure. 10 to 30% of mammal, bird, and amphibian species are currently threatened with extinction. That's in this century, by the end of this century. And that's due to a combination of factors, but the biggest factor has been our modification of landscapes, of the coast, and more recently our modification of the sea as well. We've also changed some of the big element cycles. A lot of people, of course, are very concerned about the carbon cycle and carbon dioxide in the atmosphere. I'll talk about that in just a moment. But in fact, we've changed the nitrogen cycle even more than we've changed the carbon cycle. And if you look again at a 100-year time slice, if you look at 1890, when there was very small human imprint on the nitrogen cycle, you see one very big factor. This is this figure of 100 units. Those are very big units of nitrogen, unreactive nitrogen, being fixed by biological systems so it can be used for plant growth and so on. And then there are other smaller flows of nitrogen in the system. But look 100 years later. Look at this area here. This has actually diminished the natural flow of nitrogen from the atmosphere to the land because we've changed the landscapes, as I've showed you. But there's a huge new arrow here that didn't even exist 100 years ago. And that's direct human fixation of nitrogen from the atmosphere through industrial processes, driven, of course, by fossil fuel energy, which we didn't have until the late 1800s. What this is doing is putting an enormous amount of reactive nitrogen into the Earth system. And if you just look at the other arrows, you don't need to look at them in detail. You can just see the size of them changes quite significantly because something has to happen to this nitrogen. A very small fraction of it actually goes into our food. Most of it is lost to the atmosphere, to aquatic systems, and so on. And in my view, one of the big sleeping giants in this whole global change business is the accumulation of reactive nitrogen compounds in the environment, particularly on the land. We don't know what that's going to lead to, but it's certainly going to change ecosystems and is changing ecosystems in a very big way. And of course, people are worried about the climate. And just to remind you that the climate's always been variable, that's a 400,000-year ice core record. Many of you have seen this by now. But I want to point out here is the close link between carbon dioxide and methane and temperature, which is the red curve. We're sitting here in a fairly long warm period compared to the record in the past. But notice, of course, that there have been limits on how low CO2 goes or how high it goes during this natural variability. Now, this is what's really concerning the political sector and the media now, and that's the increase in carbon dioxide. That's the ice core record for a long period of time, 400,000 years. This red bar is the extra carbon dioxide that's gone in basically in a couple of centuries from human activities. About 80% of this line here is due to the burning of fossil fuels. So you can see that we've about doubled, or even slightly more than doubled. We're about 385 now, parts per million. We've a little bit more than doubled the natural operating range. And given the links to climate, that's why people are so concerned. If you look at the climate record, there's reason to be concerned. This red line here is the observed temperature increase over the last century. That's a record of natural variability going nearly 2,000 years back in the past. And you see that this is fundamentally different from any pattern of variability you see in the past. And so a lot of what you read in the media concerns this and how we get this under control. And one of the reasons for that is it's actually finally getting through to people outside of the research community that things are happening. And one of the big things that are happening is the ice on the planet is changing very rapidly. This is the breakup of the Larsen B ice shelf in 2002. That's along the Antarctic Peninsula. But now, in addition to the shelf ice, there's real concern about the ice that lies on the land. And there are three big ice sheets, Greenland, West Antarctica, and East Antarctica. And together they would account for about 65 meters of sea level rise, which is very large indeed. But now there's concern that we may be destabilizing two of those, Greenland and the West Antarctic ice sheets, and together they would give us something around 14 or 15 meters of sea level rise. So suddenly the penny's dropping, as we say in English, in terms of the political leaders of the world, that this is serious and it isn't something for the future, it's happening now. So this is a good example of the Anthropocene.